Assalamu alaikum, everyone. I hope you can hear me and there is not a lot of echo. So, the title of my session today is Introduction to Chrome OS. So, before we go into the first slide in the agenda, let's talk about what I do and where I'm from. So, I also had humble beginnings. I started from Lahore. I started in PUCID and did my bachelor's from there. And after that, I went to Germany and basically worked at a German company. And just last year, I started working for Google. I basically work for ChromeOS Commercial. Now, what is ChromeOS Commercial? That's like we develop solutions for enterprise and education customers for ChromeOS. So yeah, let's see. This is our agenda. We will start off with an introduction. And so I will introduce what ChromeOS is. I hope everyone knows already, but I will try to go a little deeper. Not that deep, but like I'll try to give you guys an overview of everything. Then I'll talk a bit about the architecture and then how like open source ChromeOS development works. So that if you guys ever feel like being an open source contributor to ChromeOS and or Chromium, then you at least have a starting point here. So, introduction, let's see. So what is ChromeOS? I think like the gentleman before me just asked you guys how many of you know about ChromeOS? I think lots of you raised your hands, but the simple answer is that ChromeOS is the operating system used on Chromebooks. So to go into a bit more detail, so ChromeOS is an operating system, as you guys know already. It says it in the name. It was announced in 2009. It's an open source. It's an open source operating system which is built upon Chromium OS, which uses the Linux kernel. Right, and one of the main and most important things about ChromeOS is that it's very secure and it's very easy to use, right? And you can run your web apps, you can run your Android application, and you can run your Linux applications on ChromeOS. So ChromeOS, while right now it might not be a developer machine in the sense that you can't really you can write some code on it, but you can't write, operating systems on ChromeOS, but you can still do some development, and it's very easy to use. And if I have to sum ChromeOS in three words, it would be speed, security, and efficiency. So it's fast, it's easy to use, and it's very secure. So let's go ahead. Now let's talk a bit about its history. So as I already said, it was announced in 2009. I think at that time, Sundar was the product manager. Don't quote me on that, but I think they laid the open source foundation. Then there was like Chromium OS. There was an open source repository, and people were able to contribute to this repository. And in 2011, the first Chromebook was announced, and people were actually able to use this operating system. Although there were some people some hackers who had already built it and were able to run it on other systems. But the first official Chromebooks were announced in 2011 and released in 2011. In 2016, there was this project called ARC, which allowed running Android applications on this operating system, right? So you were able to run all of the Android applications on this device, on this operating system. And 2021, they announced Crostini, which allowed running Linux applications on ChromeOS. Right, so this was a brief history. In 2023, we're still working on it. We're expanding on enterprise and education sectors a lot. So ChromeOS is still going strong. So let's talk a bit about the architecture of ChromeOS. This is for the technical people. I mean, most of the stuff I'll speak about will be a bit technical, but it's still an overview because ChromeOS is very big. It has a lot of moving parts. So I mean, I don't think there are, I don't think there are a lot of people who know basically all of the stuff that is in ChromeOS. So what is ChromeOS? Like the general architecture is that it's multi-tiered. You can see you have the hardware, and then there's firmware, then you have the kernel, there's some things in the user space, and then there are basically some applications that are run, and Chrome browser being the primary, being the first and like the most important one. So as I said, it uses the Linux kernel, and whenever you start Chrome OS, what happens, it boots up, it starts the Linux kernel, and then it runs this Chrome browser application. So the Chrome browser here is actually the window manager and the user interface for this operating system, right? So everything that you see when a Chromebook starts up, it's still the Chrome browser process, which is the same as what you would have for, let's say, Windows or Linux. But it's just that like we have some build flags, so we get some additional stuff, we get some additional things that are also compiled. And primarily among them is Aura Shell, which is the window manager. And in addition to that, we have lots of user space daemons. As an example, as I've written, you have like the power daemon, the update engine, which allows updating Chrome OS, and like also the connection manager. So I talked about Chrome OS is very secure, so I had like this special slide just to talk about the security in Chrome OS, why Chrome OS is super secure. So I used this word sandboxing before. How many of you know what sandboxing is? So I think we can give someone a mic and they can tell us what sandboxing is. Otherwise I can also like continue, it's fine. So sandboxing means that like everything is run in an isolated container so that if you get a malware or something that wants to, I don't know, hack your system, then it's run in complete isolation. So like even if there is a virus, it's isolated and it won't hurt the rest of the system and won't break anything. The second point here is like verified boot. Now, what is verified boot? I mean, it sounds interesting. Well, basically what this means is that we only run signed images. So it's not possible for someone to run a compromised image on like a system which has verified boot on. So all of the images are signed by Google, and they're basically run, and like the chunks are actually verified. So it makes sure that what you're running is like the actual operating system. Then we have automatic update. I just mentioned update engine. So basically, it's a thing that allows you to actually update the device in the backend. So even if your system is compromised, but it's on, even if your system is crashing and so on, like it will still be updated in the background just because it's like a separate daemon that runs in the user space. Other than that, everything is encrypted on the device. So until and unless you log in, all of your data is encrypted. Everything that's in your user directory is encrypted, and this encryption is augmented by having like hardware security chips and like in the newer Chromebooks. So there's like this trusted platform module. They have like a security chip. You can write stuff to it, and it's secure. It's tamper resistant. So yeah. So the point being, Chrome OS is very secure. Right. Now let's talk a bit about how we develop Chrome OS. It's not development on Chrome OS, it's development of Chrome OS. So how you are how you can be an open source contributor to Chrome OS, right? So first of all, Chrome OS is open source. You can open this link right now and you can look at the code and you can look at the project, right? Once you open it, you'll see something like this. This is like the Chromium code search, super useful tool. You can look up anything. It's super, super nice. You can click on a function and it will give you the whole stack traces, like and everything, like all the call stack, and it's super nice. But like you guys can see there are two things: Chromium and Chrome OS, right? I just mentioned before this that when you start up ChromeOS, the first thing it does, it runs Chromium, right? So what is Chromium? Chromium is the Chrome browser, right? So ChromeOS, so the reason that we have these two different repositories is that the Chromium OS is the repository that has the platform-specific code. So if you have a Chromebook, it has certain hardware, right, and has certain firmware. So you need code for that hardware and firmware and some startup-specific code. Whereas Chromium repository is basically also the repository that you have for the Chrome browser. So like when you're writing code for Chrome OS, you're basically writing code in the Chrome browser, right? And yeah, let's go ahead. So two fundamentals, I just put like 2 slides on this. This can be like a 100-page presentation or even a book about how you do development. But like I'm just giving you guys like a very brief introduction on how we write code. So we have like a front-end component. I'm going to go to the next slide. So you see on the right side, you have I've opened the settings page, right? And on the left side, you have the Chrome browser process. So on the right side, all of the code that you write on the right side is still JavaScript. So we usually write it in Polymer or Lit, which is like a web components library, right? And it's written in TypeScript. The backend code is actually written in C++. Now you guys would be thinking, okay, how can you write C++ code and make it communicate with like JavaScript code? That doesn't match. Don't you need a web server in there, right? So what we do here, because the Chrome browser is a binary, is a separate process, and what you see on the right side with the JavaScript and everything is a separate process. How they communicate with something called inter-process communication. You guys might have read about it or learned about it in your operating systems course. But usually there's an abstraction over like this inter-process communication called Mojo, and we use it. I put a link there for if you want to learn about Mojo and services. It's a very, very complicated topic, but it's super interesting if you guys want to really dive deep into it. Right, so let's look at this. Let's say you open the settings page, what would happen? So let's say you want to show this Wi-Fi network, that like the Wi-Fi network is called a certain thing. So what would happen? Like the renderer process would be started, like the JavaScript code would be run. Inside of the JavaScript code, what would happen is you would use you would call like a function, which would be you would call a function from like this Mojo library. So one thing I should mention, like whenever you want to communicate between the browser and like the render process, you use Mojo, and Mojo is written in an interface definition language, right? So you write interfaces. So again, in the renderer process, what would happen as soon as you are there, it's going to call a method called getManageNetwork, and then that will trigger a method inside of the browser process, right? And then from the browser process, it will populate all of the data in this callback, and then finally the renderer process will get this data back again. Right, so this is like a very, very high-level overview of how you do development. Of course, if we put more Chrome OS stuff there, you can also have dbus calls to like platform-specific code. But like for Chrome browser and like the UI stuff, this is how you do it. You have C++ code, you have some JavaScript code, and then you communicate via inter-process communication using Mojo. Right, now, after this, this was like a very brief overview. So like if you want to know about the life cycle of Chrome or Chrome OS development, what do you do? So first things first, I have a checklist. It's very easy. You find something to fix, you fix it, you raise a patch, you get it reviewed, you submit the seal, and you wait for it to land, right? Let's see. Let's go through these like things one by one. Find something to fix. okay, how do you find something to fix? Is something broken? No. So usually what you do is, at least internally, we have like the product management team. They will tell us what the priorities are, and we will work on features or bug fixes. But if you want to be, okay, I'm not sure what this is, but if you want to be an open source contributor, what you would do is you would go on crbug.com, which will take you to like a issue tracker, and you can find a bug there. And if you like the bug and you think you can fix it, you can leave a comment there. Usually, all of these bugs, they belong to different teams. So as soon as you leave a comment, someone will get pinged. Okay, so you found something to fix, right? What would you do? The second thing, okay. So, the second thing that you would do is you need to check out the code, right? There are detailed instructions on the internet, but usually what you have to do, you have to just get this thing called depot tools. You clone it, and as soon as you have depot tools, you create a Chromium directory, and you run this command, fetch Chromium. Boom, you get Chromium. It will take 30 minutes. It's a pretty huge repository. But you will get in, once you run gclient runhooks, then you have the code in your local machine. And you can run it, you can build it. So once you have the code, what you do is you make your changes, you fix the thing, you run pre-submits. What are pre-submits? Pre-submits are basically scripts that are run right before your code can be uploaded to Gerrit. And I'll explain what Gerrit is in a second. So what these pre-submits check is basically they check if there are any like linting errors, if you're using any banned dependencies or stuff like that, right? So now, as soon as your pre-submits pass, you can upload it, and once you upload it, it will create a change list on Gerrit. Now, what is Gerrit? Gerrit is this open source code review tool that we use for open source development. It's used for Android, it's used for Chrome, and it's also used for ChromeOS. Right, so there are different aspects or like different things. So you see something like CQ build bot status, tree status, and I'll go through them one by one. So what is important, first of all, is like as soon as you create a change list, that's what we call PRs, you have to mention the bug and the test that you've written for it, the bug, which would be the bug number. In that case, would be the CR bug number that you picked up. And as soon as you basically have created this, the first thing you should do is you should click on CQ dry run, because what it does, how many of you are familiar with CI/CD pipelines? I think most of you. For those of you who are not, CQ is basically like CI/CD. So they are try-bots. What these things do, it's called commit queue. Well, what these things do is like they take your patch, they apply your patch and try to run the tests with your patch. And like if they pass, then it's all green. If they don't pass, then you'll see something like this. You see the red thing? That means like one of your build bots failed on one of your build bots failed basically, right? And then you can also see the tree status. So I only have 2 minutes left, so I will speed through it a bit. So the next thing that you have to do is you have to get it reviewed. I already said you should run the commit queue, which would be like the build bots, right? And the next thing to do would be to add reviewers. Chromium has like this concept of like all of the other Google 3 code has this concept of per directory reviewers. So you have directories, they have an owners file, and you can use that owners file to find like the reviewer that you want, that will be required. So as an open source contributor, you need at least 2 people to approve your code, and one of them should be the owner. And an easier way to find an owner is you can just click on suggest owners, but it doesn't always work. Right, now, then as soon as you have the review and everything, you can click on submit. This will trigger CQ again, and once it's submitted, it will be merged and submitted. But that's not the end of the story, because it can get reverted. You will see that Chromium and ChromeOS are like this concept of sheriffs and gardeners who are looking at the tree, so all of the build parts. So what happens is sometimes your change might break the tree, right? And the possible reason for it can be you might have written a flaky test, you might have a sanitizer failing, because sanitizers aren't run every single time with the normal build parts. They're run every few hours, right? And also rarely multiple changes might be submitted at the same time. So you should be aware of this, and you should look at the commit queue and make sure that everything is green. Right, now once you have submitted the code and it hasn't been reverted, then it will be included in the next milestone. You can look at this chromium-appspot.com schedule. It will basically tell you what the next milestone is going to be, where a change is going to land. And there are also rules around, you have rolling 4-week releases, so with 2 weeks of, 2 weeks where you can actually write code and 2 weeks where you have feature freeze. So basically that would be it. And okay, I'm just wrapping everything up. So the conclusion is that ChromeOS is a secure and easy to use operating system, has many use cases. And the second thing is becoming an open source contributor to Chrome and ChromeOS is not as hard as it seems, because I think lots of people think being an open source contributor might be difficult, especially for these big organizations. It's not. So I would encourage people to at least try to be contributors. So yeah, that was my talk. So questions? Do we have time for questions? I don't know. Okay. Okay, anyone, I don't know. Sir with the gray jacket.
Assalamu alaikum, sir. What is the difference between Gerrit and GitHub?
So Gerrit also runs Git, right? So it's Git on Borg. So it's also running Git, but the difference is that it's hosted on Google's own infrastructure, and GitHub is, I don't know. We do have mirrors of ChromeOS on GitHub, right? But if we're internally, we use Gerrit because it's nicer, has better, I don't know, review UI or something. I don't know. I don't think you can you can still review code on GitHub, but I don't know the reason why we prefer Gerrit.
मेरा एक सवाल है कि मैंने पूछना था कि क्रोम ओएस पे जो ऐप्स बनते हैं उनके लिए कोई स्पेशल फॉर्मेट होता है, या और दूसरा मेरा सवाल था कि हम विंडोज़ के जो ऐप्स होते हैं वो हम क्रोम ओएस पे कोई इंपोर्ट कर सकते हैं या क्रोम ओएस पे ला सकते हैं विंडोज़ वाले ऐप्स?
यूजुअली क्रोम ओएस के लिए आप प्रोग्रेसिव वेब एप्स और एक्सटेंशंस यूज़ होती हैं एज नॉर्मल एप्लीकेशंस बिकॉज इट्स स्टिल the Chromium browser, right? To answer your second question, there are some enterprise tools that bring, I don't know, Windows applications to Chrome OS, but I don't think they're available for consumers yet.
Assalamu alaikum. So basically my question is that for Microsoft Windows is the most widely used operating system, and then comes Apple's Mac OS, which basically has an executive feel to it. But as for Chrome OS, it is not compatible with a lot of Microsoft products and cannot support heavy applications. So what is the edge to what is the edge for people to use Chrome OS?
I would say speed and security. And stability. So right now, I mean, it's much easier to use. Chrome OS is much easier to use compared to Windows or Linux. right? And it's very fast and it's very secure. So there have been zero reported malware, I don't know, installations on Chrome OS. I read it somewhere, don't quote me on that, but like, yeah.
एक्चुअली जो क्रोम ब्राउज़र है वो ऑफलाइन फंक्शनैलिटी को कैसे एड्रेस करता है? एक्चुअली इट इज़ बेसिकली बेस्ड ऑन क्लाउड बेस्ड एप्लीकेशन मोस्टली। तो जो ऑफलाइन फंक्शनैलिटी है वो उसको कैसे एड्रेस करेगा मेजरली?
Chrome browser.
जो आपका OS है, Chrome OS।
I mean, you don't really need internet to use Chrome OS. Everything is saved on your local device. So it's a proper operating system. And you have file storage and everything. So you can save files. You have a disk, you have an SSD and everything. So yes, but you can have PWAs that are also available offline, right? Or extensions that are also available offline. Or Android applications using Arc C++.